Hello, and welcome to a short update video from my Computer Networking Assignment 1, Part 2. I just want to start out by talking about some small changes to network topology. Originally, I had planned to run the client in a browser and allow the user to use a web app to interact with the network. However, in the interest of time and due to a number of unforeseen issues, I'm going to scrap this and focus on using a command line interface, which will run on its own Docker container. That said, I've made good progress on implementing my client alongside fleshing out my actuator class, and I'm now currently in the stages of debugging these. However, they are proving to be a little bit fickle, and I'm having a few small issues, which I'll hopefully be able to resolve in the coming days for the final submission. That said, it's still functioning to the degree that I can demonstrate it. It's just all functionality is not quite working 100%. So since last time, I have implemented the command line interface for the client, and I'll show you what that looks like now. My server container is already running, so I'm going to launch up my client. I've made a short shell script in order to launch the client, as the command is a little bit obtuse. So here we go. It's the same process that we saw with the sensor last week, where the client reaches out to the server to get a unique identifier, and it's gone through this process, and now we're presented with a prompt where we can run all the commands that I've implemented. Let's start off with help. When I run the help command, we'll see a list of all the available commands. These are subject to change as I find new functionality that's lacking or some commands that might not be used very frequently. There's not much to talk about. They're all fairly self-evident. I'll talk about the sync command particularly today. I can run the sync command now, but I won't get anything because there's currently no sensor devices on the network. Let's pop over to Wireshark and we'll see what it looks like when a sensor device connects to the network in real time over there. I'm going to now run my sensor device and we'll see it send out its packet. Okay, here we see 4 UDP packets. These will probably be our new packet type and our acknowledgement packet type. Yep. We can see this here in the data section. We have new, we have the device identifier being sent back, and now we have the acknowledgement sent between the two devices. Let's pop over to the client and we'll run the sync command. So we're going to run the sync command. This will take a minute because there's some optimizations I need to make and also a few bugs in this. But you can see there's quite a spam of UDP packets. This isn't intended right now. There's just some funkiness with how acknowledgements are being handled. I'll talk about this more later. Now we can list the devices on the network with ls, and we can see that there is a new sensor type. Here's another bug where our sensor device is being listed as an actuator as well as a sensor. This will be fixed soon. Going back to Wireshark, we can see our sync packets being sent between the server and the client. This kind of sync packet indicates that it is the end. This means that there is no more devices to sync and that the client will stop looking for new devices or sync packages from the server. I plan to fully flesh out the subscription and publishing commands on the client so that once a client is subscribed to a given sensor, every time it runs sync, the server will also send on the most recent data for that sensor in the sync packets. The groundwork has been there for this to work, but my subscription packet type isn't being quite handled properly yet. And to finish up, I'd like to talk about a few limitations and things I want to fix before my final submission. Presently, I believe that a large number of the bugs I'm facing are down to the fact that I'm running sequentially the commands to get input from a user, then to receive packets, and then to send. Ideally that these will all be run in parallel, so I'm going to investigate using multi-threading in Python so I can split these 4 different distinct components into their own threads so that they don't interfere with each other. Ideally, given the time, I'll also like to implement this for the server, actuators, and sensors. To finish up, I'd like to bring attention to the fact that, as with last week, the most recent version of the code is up on GitHub, and I will have linked this in my submission. Thank you so much for watching.